Okay, so we'll continue with limits. Okay, so last class, I think we saw some rules for limit calculations, right? So
Yeah.
limit extends to something fx is equal to L means basically that LHL is equal to RHL. Left hand limit should be equal to right hand
Right
limit,
hand.
Yeah,
right?
yeah,
And limit is basically tendency to be close to a certain value. It doesn't depend on the value of the function, right?
Yeah, yeah,
And then we had rules like if limit of fx as x tends to a is L and limit of x tends to a gx is m, then you can say fx plus gx limit will be L plus minus m. And similarly for product and multiplication division also, except if division will not work if m is 0, right?
yeah,
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 yeah.
So those are basic things. Then we started looking at some standard limits, right? So some of the standard limits we looked at was sin x by x, tan x by x, I think, right?
yeah, yeah.
Right, yeah.
So I will just list down what we had seen. So limit x tends to 0 sin x by x is equal to limit x tends to 0 tan x by x is equal to limit x tends to 0 e power x minus 1 by x, right, is equal to 1. This is this is what we saw. We also saw, I think, this one, limit x tends to 0 log 1 plus x by x. That is also 1. And we saw that all of these can be derived from the Taylor series expansion of the corresponding functions. Taylor series expansions we saw. So for example, any fx can be written as f of 0 plus x power 1 by 1 factorial f dash 0 plus x power 2 by 2 factorial f double dash 0 and so on, right?
Yeah,
Yeah,
yeah.
yeah,
And if you use that for sin x, tan x, e power x, log 1 plus x, you will get series for all of those, infinite series,
mm,
right?
yeah,
And those series can be easily used to get all of these limits,
yeah,
right?
yeah,
Yeah, yeah.
So that was fairly straightforward. You need to remember series for at least sin x because you don't want to keep deriving it all the time. So remember the series for sin x, series for cos x. Cos x is 1 minus x squared by 2 factorial plus x4 by 4 factorial minus x6 by 6 factorial, so on. And e power x is 1 plus x squared by 2 factorial plus x cubed by 3 factorial and so on, right?
yeah,
And log 1 plus x is x minus x squared by 2 plus x cubed by 3 minus x4 by 4. This is very simple. Alternating signs and powers and denominator match,
mm,
right?
mm, yeah,
These four at least you should remember. We also saw this limit x tends to a, x tends to 0. 1 second. Limit x tends to 0 a power x minus 1 by x is equal to ln a,
yeah,
right?
Yeah,
We
yeah.
we saw that by writing a power x as e power x ln a, right?
yeah,
You
yeah,
remember that, no? We
yeah,
wrote a power x as e power x ln
excellent.
a, right? So instead of x, you have x ln a, right? So you should put ln a here, right?
Yeah, yeah,
Then it is looking like the same thing. E power something minus that by something. That part becomes 1 and ln a is left, right?
yeah, yeah,
You understand? Everyone understands what I'm saying, no?
Yeah,
Yeah.
yeah.
So this is also important. Also, you could derive it in an alternative way by just doing a power x Taylor series. But a power x Taylor series will be very similar to this, except every term has ln a square, ln a cube, and so on.
Yeah, yeah.
Okay. So that can be done by derivatives here. So these things we saw. We also saw how did we get e power x definition. E power x is basically limit x tends to 0, 1 plus x to the power 1 by x, right?
Yeah.
Yeah.
We saw this by doing binomial theorem on this.
Yeah. Yeah.
Binomial theorem on this. So basically, if it was limit x tends to 0, 1 plus 2x to the power 1 by x, it would give answer of e square,
E square.
right?
Yeah.
Because what we realized is whenever we get something like this, limit x tends to 0, 1 plus fx, or x tends to a, 1 plus fx to the power gx, such that limit x tends to a fx is 0 and limit x tends to a gx is infinite,
Okay.
then the
It's E
answer
to the
comes
power.
e power limit x tends to a fx into gx. Okay, so this is a standard thing, but this is actually a trick in the sense that it is only valid because this is happening. It is only valid because e power x is defined as this. So you should be able to recognize this pattern. You should see that it is 1 plus 0 to the power infinity. And both of these things are tendencies, right? It's not exact value of 0, right?
Yeah.
Then
Yeah.
it will be this e power limit thing, right? So that we saw. Also, now we also have certain, I think we did not discuss L'Hopital's, right? L'Hopital's rule, did we discuss? No.
sir.
No.
Okay. So L'Hopital's rule is very simple. So before that, I think we also discussed this limit. Limit x tends to a, x power n minus a power n by x minus a. This is n a n minus 1, right? How do we do this? We just factorize it. Factorize x power n minus a power n, and you can write it as x minus a into x power n minus 1 plus x power n minus 2a, and so on till a power n minus 1, right?
Yeah.
So you then cancel factors and then put x is equal to a, you'll get n a n minus 1, right?
Yeah.
Okay, so that is something we saw. Now let's look at this rule called L'Hopital's rule. So L'Hopital's rule is basically a nice method to evaluate certain types of limits. What are the types of limits that you can evaluate by L'Hopital's? So there are only two types, 0 by 0 or infinity by infinity. Like whenever you see an expression where if you put the limit value, it comes like this, right? Then L'Hopital can work, okay? So this is like basically the form of the limit. Like, for example, limit of x tends to 0 sine x by x, it is in what form? It is in 0 by 0 form, right? There,
Yeah.
we already know that it is 1. We have derived it by geometry, but we can do it by L'Hopital's rule. And what is the rule saying? It says that whenever you have limit x tends to a fx by gx, such that both fx and gx tend to 0 or infinity, right? Then this limit is equal to, this limit, let's say it is called L. This limit is equal to limit x tends to a f dash x by g dash x. Okay, or it could also be equal to limit x tends to a f double dash x by g double dash x. And you can keep doing the derivatives till the 0 by 0 form is gone, till 0 by 0 infinity by infinity form is gone. So basically, what is it saying? It's saying if you have this form, keep differentiating numerator and denominator and checking whether the form is disappearing or not. And you have to stop at the stage where it disappears. Okay.
Yeah.
So
we have to keep differentiating until it becomes 0 or.
Until it becomes not 0 by 0.
Oh, okay, got it. Yeah.
It should not be 0 by 0 or infinity by infinity. At that point, whatever the value comes, that is the answer.
Yeah.
Okay.
So for example, here sin x by x, for example, right now it is 0 by 0, but the limit will be equal to differentiation of this cos x by 1, right? And if you put 0 here, automatically you're seeing it is 1, right?
Yeah, yeah.
The form is gone. No?
Right, yeah.
So this is the step where you end, right? So
Yeah.
this can be, actually Hopital is super powerful and it can give you many times the answer very quickly because
Yeah.
differentiation is easy and you can easily put it, right? But because it is so powerful, questions are often designed where it is discouraged to use Hopital. Like they will design a question where differentiating will be super painful. Okay. So you should be on the lookout if Hopital can be used, but you should not be like, I only know how to do Hopital, right? Many people get to that stage where they are calculating limits and they only know one thing, Hopitals, and if it doesn't work, then they cannot find it, right? So don't be into that situation. Like don't rely on it so much that you only know this. Everything else that we have discussed so far is super important as well, right? So,
Yeah.
however, you will see that all the standard limits are easily, that we have seen so far, all the standard limits are easily coming from Hopital, okay? So see, this is also 0 by 0, but sec square x by 1 is not 0 by 0, right?
Yeah.
So this is 1. E power x minus 1 by x, this is also 0 by 0, but e power x by 1 is not 0 by 0. So this is 1, right? Right?
Yeah, yeah.
All the standard ones that we have seen so far are easily solved by Hospitals, but there is a reason why I did not discuss Hospitals in the beginning, because I don't want you to only know Hospitals. Okay, so the series method is more general and it will work in more cases, even though it is slightly long. Okay, the series methods like, okay, I'll discuss that, but first check this out. This is 0 by 0 if x tends to a, then differentiation is nx n minus 1 by 1, right?
Yeah.
So x tends to a, answer is na minus 1, right?
Right.
Yeah.
It is not no longer in 0 by 0 form, right?
Yeah.
So very easy to use this rule, but what are the rules that you should see first? Whenever you see a limit, you should think of, is it possible to factorize and remove the problematic factor, remove the 0 in the denominator, right?
Yeah.
Is it possible to, sometimes rationalization works. So if there are irrational things, right, then you like, for example, something like this suppose is there, right, and you have to find limit x tends to 2 or something, right? Correct.
Yeah.
X tends to 4, actually. X tends to 4, and on top should be something, I mean, I'm just making up the question, so obviously this is not correct, but you should have something like x square minus 4 on top, right? Let's say. So if you rationalize it, I mean this, multiply it by this. Okay, maybe I should not have put x square minus 4, I should put x square minus 16. Okay, what will happen is this part will become x minus 4, no?
Yeah, yeah.
And x minus 4 will cancel here. It will become x plus 4. And
then
then you can put the limit easily, right?
Yes, yeah, yeah.
So I'm just making up this example, but you'll see cases where rationalization is a nice way to get the answer. Whenever there's some irrational thing, multiply by conjugate up and down, right?
Yeah.
So that is a method. Then third method for us is convert to a standard limit. Convert to a limit that you already know. Convert to a standard limit. So you can see problems like, for example, limit of x tends to 0 sine 2x by 3x, right? So obviously it is not sine x by x, but it is very close to sine x by x.
Yeah, yeah.
Okay, what you can easily do is sine 2x by 2x into 3 by 2, right?
Yeah. Yeah.
And remember that this sine x by x limit is 1 only if the inside part and this part should match.
Same.
Yeah.
Yeah, yeah.
It should be the same. It cannot be 2x and 3x, okay? It should match and both should tend to 0, right?
Yeah.
Right, yeah.
Which is happening now. So answer will be just this 2 by 3, right?
Right.
So convert to a standard limit is a powerful thing. Like for example, e power 2x minus 1 by x, right? Limit. So I can easily say that what it will be, because I'll just do 2 into 2 and then this part is 1.
Yeah.
Because it is my standard limit here, right?
Yeah.
And with the standard limit, the condition is that the top and the bottom must match, okay? And both should tend to 0, right?
Yeah.
So basically what I'm saying is, don't try to differentiate here if you can convert to standard limit, right?
Right.
Like use L Hopitals only when required. Don't use it when there are easier methods to solve, right?
Yeah.
This is the fourth thing, and the last thing is series expansion. So series expansion will probably take the most amount of time, but it is guaranteed to work. Okay.
Yeah.
The other methods may or may not work. Series expansion should mostly work all the time. Okay. So that is by Taylor series. Okay. And by standard limits, I mean all of the standard limits that we saw so far. Okay. Even the limit x tends to a 1 plus fx to the power gx1, which is limit x tends to a fx gx, as long as fx tends to 0 and gx tends to infinity. Right?
Yeah.
So these 5 major strategies you have, and that is what you will be using in most of the problems. Okay. So that's all for limit calculations. What we will do now is problems. And we'll see a few problems and see if we are able to solve them or not. Okay.
Sir, actually I was trying a couple of questions. So I have a doubt in one question. So can I just read the question out?
Where is it?
It's in a Allen book.
Just send me a picture. No, don't read it.
Okay, just a minute.
Send me a picture on the group.
Yeah, I'll send it.
You're sending?
Just a minute. Sir, I sent it.
Cos 2 minus cos 2x, limit x tends to minus 1. Okay. Limit x tends to minus 1. Cos 2 minus, what is it? Cos 2x by x square minus mod x. Right? See, this is the question, no?
Yeah.
Okay. So x tends to minus 1 first of all. So what I will think of is mod x will be minus x near that thing, right? Near the limit, right?
Yeah.
So I will just write cos 2 minus cos 2x by x square plus x, right?
Yeah.
Correct? Okay.
Yeah.
Great. So cos c minus cos d formula, 2 sine c plus d by 2. So it is 1 plus x, and sine d minus c by 2, right? So 2x minus 2. So x minus 1, right?
Mm.
Yeah.
By x square plus x. So now you can see that x, it becomes 2 sine x plus 1 by x plus 1, right? And sine x minus 1 by x, right?
Yeah. Yeah.
Limit x tends to minus 1.
All right.
So this part will become 1 because 0 and 0.
Yeah.
This is standard limit. This
Yeah.
part becomes 1.
Yeah.
And when you put minus 1, what comes? No, there is no problem only. 2 sine minus 2 by minus 1, which is minus 2 sine 2 by minus 1. So basically 2 sine 2. Right?
Right.
So this is the way that I want you guys to solve. You could also have solved by L'Hospitals though at this stage.
Yeah.
Right? You can do immediately L'Hospitals at this stage and it becomes minus 2 sine minus minus plus 2 sine 2x, right?
Yeah.
By 2x plus 1, right?
Mm.
And that gives you the answer directly,
Yeah.
right? L'Hospitals is faster, but not all problems will be this easy where you can put L'Hospitals. Everyone is understanding?
Yeah.
Yeah,
Yeah.
yeah.
Yes, sir.
In general, look for standard limits first. If you know that, okay, this problem is easy and I can apply L'Hospitals, then go for it. But don't rely on that always.
Yeah.
Okay. Any other doubts?
No, sir.
Okay, then question number, this is a question. If alpha and beta are roots of equation ax square plus bx plus c is equal to 0, then find the limit x tends to alpha 1 minus cos ax square plus bx plus c by x minus alpha whole square. This is the question. Don't use L'Hospitals. L'Hospitals is forbidden. Do without L'Hospitals.
Hmm.
Everyone can solve it by L'Hospitals, right? There is no issue only.
Yeah.
Like that is a straightforward thing to do.
Yeah.
Okay. So we'll not do that. We'll do it without that. Anybody getting any ideas? Make use of this fact that ax square plus bx plus c quadratic can be written as a into x minus alpha, x minus beta. Right? Because alpha and beta are the roots.
Yeah.
What are you guys trying?
We write it as 2 sine square.
That is correct. 1 minus cos theta is
2 sine
2 sine
square.
square theta by 2. So it becomes 2 sine square ax square plus bx plus c by 2 by x minus alpha square, right? And then write it as a into x minus alpha whole square, x minus alpha, x minus beta by 2, right? Divided by x minus alpha whole square, right?
Yeah.
So now notice that this part is disappearing to 0. So you need a corresponding part denominator also, right?
Yeah.
And you have square here. So you need a square x minus beta whole square by 4 in the denominator, right? Then only it will match completely, no?
Yeah.
Right. Yeah.
So you have to multiply by that a square x minus alpha x minus beta whole square by 4 because I have arbitrarily multiplied here, right?
Yeah.
Now notice that this whole thing
becomes 1.
will be 1 because sine x by x is 1.
Right.
And
but this is sine square x, right?
because it is sine x by x whole square.
Oh, like that, right? Yeah.
It is sine x by x limit only, no whole square of that.
Right.
Yeah.
So this is tending to 1, so 1 square. And the answer will be basically a square alpha minus beta whole square by 2 because there is a 2 here.
Yeah.
Okay. So
Yeah.
if you try to actually differentiate, no, it will happen, but it will be still quite annoying. Like you'll have to do it 2 times. Okay. First time when you differentiate, x minus alpha will still be there, no? You understand? It will be sine of the quadratic by 2x minus alpha, right? And then next time again you have to do. Okay, actually it will have some other terms also.
Yeah, the
chain rule terms.
Right,
2ax plus b will also be there.
Yeah.
And then second time also you'll have to do because this numerator is 0 and this denominator is 0. Second time you'll have to do by product rule differentiation, right?
Yeah.
So anyway, it is going to become long and you're likely to make mistakes if you do L Hopitals. So think of these things. Think of these trigonometric identities that you can utilize to solve this and utilize your knowledge of sin x by x is 1, right?
Yeah.
Yeah.
Okay. Then next one is okay. Question 3. Let px be equal to a1x plus a2x square plus a3x cube plus so on till a100 x power 100, where a1 is 1, ai belongs to r for all I goes from 1 to 100. You are supposed to find limit of x tends to 0, 100th root of 1 plus p of x minus 1 divided by x. 100th root of 1 plus p of x. So one method is fairly clear, L Hopitals. Okay.
Yeah.
Because it is numerator is 0 and by 0. So what you can do is 1 by 100, 1 plus p of x to the power 1 by 100 minus 1. So minus 99 by 100 multiplied by differentiation of the inside part, so p dash x, right?
Yeah.
Divided by 1, right?
Yeah.
So now it is no longer in 0 by 0 form, so you can put the values. So notice that p of 0 is 0, right?
Right. Yeah.
So it is 1 by 100. This is 1 power minus 99 by 100 multiplied by p dash 0, right?
Mm-hmm.
And once you differentiate this, p dash x will be a1 plus 2a2x and so on, right?
Yeah.
Yeah.
And
So
p
A1.
dash 0 is simply a1. So this becomes a1 by 100, right?
Yeah. Yeah.
This is
Yeah.
a1 by 100. That is one way to do it. The other way to do it is by binomial theorem, where you say 1 plus px to the power 1 by 100, right?
So
Minus
we
1.
can use binomial approximation.
Not approximation, actually the correct series only. 1 plus 1 by 100 into px plus next term will be 1 by 100, 1 by 100 minus 1 by 2 into px square, right? And so on, right? Minus 1
Yeah.
by x, right? So
Yeah.
now 1 and 1 will cancel, and you have 1 by 100 by px by x plus these terms, right? Correct.
Yeah.
So notice that px by 1 by 100, px by x. Px by x is what? a1 plus a2x plus so on, right? Plus
Right.
some constant into px whole square by x, right? Px whole square will ensure that the lowest coefficient will be square, right? And on top.
Yeah.
And when
Yeah.
you divide by x, you will still have x terms in everything, right?
Yeah.
And then you have to put x tends to 0, this will disappear. This will disappear. You will get a1 by 100. Right?
Mm-hmm. Yeah.
Yeah. Yeah.
Correct. So two ways to do it: binomial theorem or
Sir, can you
L'Hopital's.
explain the last part again?
Px whole square will be what? The lowest power will be square, no?
Yeah.
So when you divide px whole square by x, even in a1 there will be x left.
Oh, okay. So those all will become 0. Right. Got it.
Everything forward is 0. And
Yeah.
here everything here till here is 0, only a1 is left.
Yeah. Got it.
Okay. Then the question is, okay. So the question is like this: let alpha, beta be roots of ax square plus bx plus c is equal to 0, where 1 is less than alpha is less than beta. Then limit of x tends to m mod of ax square plus bx plus c divided by ax square plus bx plus c is equal to 1 when a. Actually, this is very easy. I should not have picked this, but yeah. Just tell me. These are the options, okay? This is actually a quadratic equation question actually. All of you should be getting the answer here, I think.
Yeah, just a minute.
Draw the graph of the quadratic, you'll get the answer immediately. These are the two cases, no?
Yeah.
So in case one, if you see, this is the quadratic, one is here, alpha, beta, roots here. So when will the mod part be positive? When the quadratic is beyond the roots, no?
Right, yeah.
This portion and this portion, the mod is positive and it will cancel and become one, no?
Yeah. Yeah.
So your m should be here or here, right?
Yeah.
So this is wrong, no? Because m greater than 1, it could also lie here, no? Then it will be wrong,
Yeah.
Yeah, yeah.
right?
Mhm.
If a is less than 0, it will be positive in between the roots, no?
Right, right.
Yeah.
A is less than 0, m should be in the roots when this part is positive, no? Quadratic.
Yeah.
Yeah, yeah.
So this is clearly right,
See.
right?
Yeah, yeah.
This is clearly right, no?
Yeah.
Other cases, there will be some problem somewhere. You can verify for yourself. If a is less than 0, m is less than 1, right? M is less than 1 is negative clearly, right?
Yeah.
It is in this region, m is
Yeah.
less
Yeah,
than 1.
negative, yeah.
So then mod is negative, then it will become -1 should be the limit.
Mhm.
Correct, yeah.
Everyone is understanding, no?
Yeah. Yeah.
You don't have to do anything in this. Just draw the graph and see the options. Right?
Yeah.
Okay. Okay. Next one is fx is equal to cos 2x, cos 4x, cos 6x, cos 8x, and cos 10x. You have to find out limit of x tends to 0, 1 minus fx whole cube divided by 5 sine square x. See, this is the type of problem that I said that they will make a problem so that you can't use L'Hopitals. Don't even try to differentiate this. Are you understanding?
Yeah.
This is in 0 by 0 form, but
Right,
you have
yeah.
to do at least 2 times, right? Like denominator also becomes horrible. Sin x, cos x, you have to do by product rule.
Yeah.
Mm-hmm.
So it will not be nice if you try L'Hopital. So do something else. See, you can easily simplify fx by multiplying up and down by sine 2x, no?
Right.
Because you can use double angle formulas repeatedly.
Yeah.
Right.
So
Works
this
with
will
it.
become half sine 4x into
Oh, yeah.
cos 4x. So
Right,
this will
yeah.
become 1 by 4 sine. Oh, wait, 6 is there. So then there is a problem because of the 6. Okay, so this will not work then. Okay. Fine. So then don't do this. Let's do something else. I thought for a moment that it is 4, 8, 16, right?
Yeah.
Then it would have worked, but right now it won't work. So let's see this expression and let's try to simplify that. Limit x tends to 0, a cube minus b cube, no?
Yeah.
So 1 minus fx, 1 plus fx whole square, right? By 5 sine square x, right? Correct.
Yeah,
Now
yeah.
notice that fx tends to 1 as x tends to 0. Correct?
Yeah.
Correct, yeah.
So this part is no longer a problem for you, right?
Yeah.
So therefore, it should be 3 by 5. It will be 1 plus 1 plus 1. Limit of x tends to 0, 1 minus fx by sine square x, right?
Yeah.
Correct?
Right.
Okay. Now, this part you have to evaluate somehow. So how do we do it? 1 minus
Now
cos.
we need to
Huh?
multiply and divide by in the denominator.
Now we need to what?
In the denominator, can you multiply and divide by x square? So that you get this.
Multiply and divide by x square, you're saying.
Yeah.
This part will become 1. So, okay, then you will end up with this.
Yeah.
Okay. Now this part we have to think about what to do. 1 minus cos 2x, cos 4x, and so on, divided by x square. So how do we evaluate this one? Right now it is 0 by 0 form, but differentiation is painful. So I have to convert it into some nice form. So, okay, what I will do is I'll combine 2 and 10 and 4 and 8, right? 2 and 10 addition is 12, 4 and 8 addition is 12, right?
Yeah.
So let's do that combination, because then it will split it into multiple parts. So what I'm saying is cos is what? Cos c minus d plus cos c plus d, no?
Yeah.
So 1 minus half of cos this and this I'm doing. Half because 2 into that, right? So it will be cos c minus d, which is cos 8x plus cos c plus d, so plus cos 12x, right? Multiply by half, 4 and 8 I'm doing, so cos 4x plus cos 12x, right?
Right.
And multiplied by cos 6x, right? Correct.
Yeah.
So it becomes 1 minus 1 by 4. Now it is becoming, there are two factors like this and a cos 6x, right? So let's multiply this and this and split those also, right? So what I'm saying is cos 8x cos 4x plus cos 8x cos 12x plus cos 12x cos 4x plus cos square 12x, right?
Yeah.
And multiplied by cos 6x, right?
Yeah. Yeah.
Okay. This will itself become half of cos 4x plus cos 12x, right? Plus half of cos 4x plus cos 20x, right? Plus half of cos 8x plus cos 16x, right?
Yeah.
Plus half of 1 plus cos 24x, right? Multiplied by cos 6x, right?
Right.
Basically keep doing it forever and ever, right? One more time you have to do.
Okay.
You understand what I'm saying?
Yeah.
It is a little long, but is there some smarter way to do it?
Sir, in that limit, in that 3 by 5 limit x tends to 0, 1 minus cos 2x, in
Hmm.
that part, if we try splitting them and then
Splitting what?
converting it like that term itself, like 1 minus cos 2x, cos 4x,
So
if we
how do you
somehow
split?
try to split it and make it into a form of
See,
for cos,
no matter what happens, no, this will be a long question only. Okay. Whatever
okay.
you do, L Hopitals also you'll have to differentiate a product of 5 things.
Yeah.
Right?
Yeah,
And
yeah.
right now what I'm doing is also super long. Okay. There is no short way to do it. Okay.
Right.
I mean, as far as I know, there is no short way to do it, but let me think. Is there some way to get this faster? Do you realize what to do? Like, do you understand how it will be solved right now? Even if it is super long, do you know what I will do? I'm just writing this whole thing, okay?
Yeah.
And when I put the cos 6x inside, I will take one more time half of and all, right?
Yeah. Yeah.
So then after that, at the end of all of it, you will get things which you can put the values of,
Okay, okay.
right?
Yeah.
No, you should get some sine square, right? Okay, actually you'll get one. You will get groups of terms. Groups of terms like cos, cos. What you will have to do is put it in some form of sine square. No, so finally 1 minus cos 2x is what? It is 2 sine square x. Finally, you have to do this, okay?
Yeah.
You understand why finally you have to do, because denominator is x square, no?
Yeah, yeah.
Yeah. Yeah.
It finally has to come as some sine square x on top, right? Then only you
Yeah.
can get it as
Yeah.
something.
Yeah,
So
yeah.
you cannot put values directly. You have to first convert it into many causes and then do 1 minus cos 2x is equal to 2 sine square x for everyone. You understand?
Yeah.
So it is really annoying, but right now I don't know a better way. Better way could be if you try, no, but that differentiation will be super annoying. Don't try to differentiate also this.
Yeah.
Let me think if there's something else. Okay, what am I doing? I think there's an easy way out. Wait. 1 minus cos 2x, cos 4x, cos 6x, cos 8x, cos 10x, right? By x square. Okay, directly split it into 1 minus sine square. No, why am I doing all that? Write cos 2x as okay, this is way better. You understand? Nobody is understanding.
Yeah, understood.
Yeah.
Then
Yeah.
So it is still some multiplication, but it is still not as bad as that. No? It is just 1 minus something, 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 multiplication, right?
Yeah.
So,
Yeah.
so first term will be 1, then next term will be sum of all of these, right?
Right.
2
Right,
sine
right.
square x plus 2 sine square 2x plus 2 sine square 3x, right? Plus 2
Yeah.
sine square 4x plus 2 sine square 5x, right?
Yeah.
And after that, the terms will have 2 at a time, no? Like suppose you have 1 minus a, 1 minus b, 1 minus c. This product is what? 1 minus a plus b plus c plus ab plus c bc plus ca, those type of terms, no?
Yeah.
Right? So
Yeah.
it will be product of this and this, right? 2 at a time products, right? 2 at a time products, then 3 at a time products with a minus sign. You understand what I'm doing?
Yeah.
Yeah. Yeah.
And then denominator is x square. Okay, I don't care about the 2 at a time, 3 at a time products, because 2 at a time, when you do a product, there will be sine power 4, no, somehow sine square into sine square, right?
Yeah.
And sine square x by x square limit will tend to 1, but there is still a sine square 2x left, right?
Right. Right.
Which will tend to 0, right? You understand what happens when you do this? 2 sine square x, 2 sine square 2x by x square, limit as x tends to 0, right?
Yeah.
I'm talking about one term in this bracket, right? So this part tends to 1, but this part tends to 0, so it is 0, right?
Yeah.
When you do 3 at a time also, obviously every term will be 0 from this point forward, right?
Yeah. Yeah.
Yeah. Yeah.
Correct. So now what I will be left with is basically this thing, right?
Yeah.
So notice that 1 minus this thing, no?
Mm-hmm.
Yeah.
Right? Because this product itself is 1 minus this, right?
Yeah. Yeah.
So the answer will be 1 minus 1 will cancel and it will be plus 2 sine square x plus this plus this plus this plus this by x square, right?
Right. Right. Yeah.
Is everyone getting what I'm saying?
Yeah.
Yeah.
So now your answer will be limit of x tends to 0, 2 sine square x plus 2 sine square 2x plus 2 sine square 3x plus 2 sine square 4x plus 2 sine square 5x. All of them are divided by x square. So
Mm-hmm.
that is doable because this is 2, right? This is 4 and 4, right?
Yeah.
Now it is 1. You understand? Multiply by 4 on the denominator so that it becomes 2x whole square, right?
Yeah.
So you have to multiply on the numerator also by 4. So it will be 2 plus 8.
Oh, right.
Multiply by 9 here. So multiply by 9 here. So that now this part is 1.
Yeah. Yeah.
So plus 18. Multiply by 16 here and 16 here. So 32. Multiply by 25 here and 25 here, right? So 50,
Yeah.
right?
Yeah. Yeah.
So this will become basically 10 plus 18, 28 plus 32, 110, right? Something like that.
Yeah. Yeah.
110 only, no? 110, right? And you had 3 by 5 of that outside, right?
Yeah. Yeah.
So that becomes 66, which is the answer. Okay, so there was a clever trick here, but it is not immediately obvious how to get that. So I'll just quickly revise what happened. This was the thing, okay? This was the function, and there was a sine square x here, right?
Yeah. Yeah.
And what we did was converted it to a cube minus b cube formula. 5 sine square x was here. A cube minus b cube formula gave me 1 minus fx, 1 plus fx square by 5 sine square x, and we wrote sine square x by x square into x square, right?
Right.
So this part became 3. So it became 3 by 5 limit of x tends to 0, 1 minus fx by x square, right?
Yeah,
Yeah.
yeah.
Just hold on for a moment, I'm getting a call. Hello. Yeah. So this was the stage where you're at, and then how did we do it? We multiplied it, right?
Yeah.
Hmm.
We converted into sines squares and then multiplied. And then you have to be clever that you don't have to evaluate all the products, okay?
Yeah.
You only have to worry about the first two terms. Everyone understood, no?
Yeah.
Yeah. Yeah.
Okay, fine. Then next one is question number, what number was it, no? Okay, fine. I'll just pick a number. Limit n tends to infinity of 4 power n by 4 minus root 3 plus 2 sine theta to the power n plus 2 exists. This limit exists and is equal to p. P is not equal to 0, where theta belongs to 0 to pi by 2. Then find p plus cos theta by p. Okay. Everyone has understood the question.
Yeah. Yeah.
You
Yeah.
have to find the limit. If you can find the limit, then it's over.
Yeah.
So nice question. Think about this inside part. Okay.
Can we try this by replacing n with 1 by x or something like that, which makes the 4 to the power n as, no wait,
1 by x won't help.
yeah, it won't help. I just realized.
Think of what this inside part is. How much is the value of this inside part, right? So like suppose I gave you something like this, a power n by b power n, right? So basically a by b power n, limit n tends to infinity, right?
Yeah.
So as long as a by b, if it is greater than 1, then the limit is infinite, right? So limit does not exist, right?
Right.
If a by b is less than 1, limit is 0, right?
Yeah.
And if a by b is equal to 1, limit is 1.
1. Yeah.
So only possible values are 0, 1, and infinite, right?
Yeah.
So infinite is not possible because it says limit exists. T is equal to 0 is not possible, right?
Yeah.
So by the way, the expression right now is not a by b power n. It is n plus 2 here and n here, right?
Yeah.
So let's write it like this. Limit n tends to infinity 4 power n by 4 minus root 3 plus 2 sine theta power n and multiplied by 4 minus root 3 plus 2 sine theta square, right?
Yeah.
So now this is now a by b power n, right?
Isn't it
Right.
better to do 4 square up and down because it's easier than
Yeah, you could do that also.
because then n plus 2 will be the same and then we won't have any root.
That's also fine. That doesn't change anything though. So it will be the same amount of effort eventually also. So anyway, you have to think about this part, okay?
Right.
A by b part you have to think about. So right now I'll just continue from what I've written. Otherwise you can do n plus 2 on top. That doesn't change anything. You have to multiply by 1 by 16, right?
Yeah.
Right. Yeah.
That is also same thing. So limit n tends to infinity, you have 4 by 4 minus root 3 plus 2 sine theta whole power n divided by 4 minus root 3 plus 2 sine theta whole square, right?
Yeah.
Now let's think about this thing. If this thing is greater than 1, right, then limit does not exist. If it is less than 1, the limit tends to 0, right?
Yeah.
Right. Yeah.
So both cannot be happening, right?
Yeah.
It must be 1. So you should have 4 by this should be 1, right? So you will therefore have 4 is equal to 4 minus root 3 plus 2 sine theta. So you have sine theta is root 3 by 2. So theta is pi by 3, right?
Yeah.
In that case, this part is 1. So this limit is gone. And theta is pi by 3. Then this part is becoming root 3 by 2. Root 3 cancel. 1 by 16 is coming, right?
Yeah.
1 by 16 is coming. And that is your p value. And now you can find this 1 by 16 plus cos pi by 3 is half by 1 by 16, right? So 9 by 16 by 1 by 16. So answer is 9.
9. Yeah.
So this is an example of the situation where you have a limit tending to infinity. So you should realize that whenever something tends to infinity, if that something is greater than 1, the answer will be infinite. And if that something is less than 1, then the answer will be 0, right?
Right.
That is the thing that they are using here. Okay. Then question 8 is the value of limit x tends to 0 plus. 0 plus means right hand limit, right? E power x minus 1 minus x power x by x square power x minus 1 whole square. Okay,
Mhm.
this is the whole limit. So think about it. You should think of x power x as a variable sort of, right? X power x minus 1.
Mhm.
See, the denominator can be written as x2 minus 1 whole square, right?
Yeah,
Yeah,
yeah.
yeah.
Right? That's the same thing.
Hmm.
So this is x power x minus 1, x power x plus 1 and whole square, right?
Right, right.
So this is x power x minus 1 whole square, x power x plus 1 whole square.
Yeah.
So that is a better way to write the denominator.
Mhm.
Now on top, you have this thing. Right now it looks weird, but what I will do is this. Minus 1 plus 1 minus this, right?
Mhm.
By x power x minus 1 whole square, x power x plus 1 whole square, right?
Right.
Yeah, yeah.
Now I can isolate this a little bit because what I have is e power x minus 1 minus 1 minus x power x minus 1, right?
Yeah, yeah, yeah.
By x power x minus 1 whole square and x power x plus 1 whole square, right?
Right.
Now think of your Taylor series expansion for e power x, right? Think of the Taylor series expansion because that will be useful at this stage, because e power x used to be 1 plus x square by 2 factorial plus x cube by 3 factorial and so on, right?
Hmm.
Yeah, yeah.
So this is my power of e. So that will be 1 plus x power x minus 1 plus x power x minus 1 whole square by 2 factorial plus x power x minus 1 whole cube by 3 factorial and so on.
Yeah.
Right, right.
And then from there you subtract the first term and the second term, right?
Correct.
Correct. So you're getting ending up with this part on top, right?
Right, right. Yeah.
Yeah.
And then you divide by x power x minus 1 whole square, right?
Yeah, so cancels. Yeah.
So
Yeah.
you're ending
Yeah.
up with 1 power here, right?
Yeah.
Correct. So you're getting 1 by 2 factorial plus x power x minus 1 by 3 factorial plus so on, x power x minus 1 by 2 factorial by 4 factorial and so on, divided by x power x plus 1 whole square, right?
Yeah. Yeah.
Limit of x tends to 0, right?
Yeah, yeah.
Okay. Now you need to realize one thing. What is limit of x tends to 0 positive of x power x, right?
Hmm.
Unless you can figure this out, you will not be able to solve it, right?
Yeah. Yeah.
Right. So this part we have to figure out. So let's think about it. Okay. So why don't you please copy down this part that we have gotten somewhere, because we'll come back to it.
Hmm.
Okay. Limit of x tends to 0 plus you have this expression.
Yeah,
Everyone
yeah.
has understood how I got this expression.
Yeah.
Yes, sir.
Yeah.
Yeah.
A square minus b square whole square, and then on top I put a minus 1 plus 1 to get terms like this. This
Yeah.
looks like a nice series expansion of e power x. First two terms are being cancelled. And then I divided by the denominator and got this. So just copy it down once, and then we'll think about this limit, because we need to know what the value of this is tending to be.
Yeah.
Mm-hmm.
Okay. So you have copied it down?
Yeah.
Okay.
Yes.
So limit x tends
Second.
to, what happened? You have not written it.
Oh. Yeah, I was writing it on. Yeah, I wrote it.
Okay. So limit of x tends to 0 plus x power x. So whenever I have told you earlier, then when you have to do this 0 plus sort of a thing, you can write it as limit h tends to 0 f of 0 plus h, right?
Yeah.
Right. That is the same meaning as here it is f of x, right? 0 plus.
Yeah.
So basically I can write this as limit h tends to 0 h power h, right? Where h is always a positive quantity, no?
Positive. Yeah.
Yeah,
Right.
yeah.
So let's try to think of this limit. Let's say this limit is equal to t. Let's say it is t. If I take log on both sides, I will get limit of h tends to 0 h log h is equal to log t, right? Okay. And log h okay, this part I have to figure out. So this is basically log h by 1 by h, right?
Right.
Correct.
Yeah, yeah.
So 0 log 0 happens at near 0. Log graph is like this. So it tends to minus infinity, no? The top part. Top part tends to minus infinity and the bottom part is tending to infinity. 0. No, infinity.
Infinity, yeah.
Yeah.
Right? Okay. So I'm wondering if I can use L'Hopitals here. If I use L'Hopitals, what happens? 1 by h by minus 1 by h square. So you're getting 1 by h and minus h square. So minus h, right? So you're getting this limit is tending to 0, right?
Right. Right. Yeah.
Because now this is no longer in L'Hopital's form infinity by infinity, right? So if this is tending to 0, that is equal to log t, then t should tend to 1, no?
Yeah. Yeah. Yeah.
You understand? This part I'm saying is log h by 1 by h and it is of the form infinity by infinity, right? And
Yeah.
I'm saying if I do L'Hopitals, I'm getting 1 by h minus 1 by h square and minus 1 by h square, so minus h, but h tends to 0, so it is tending to 0. So this tends to 0, then log t is 0, then basically that means t tends to 1, right?
Right, yeah.
Yeah.
So limit x bar x tends to 0 plus x bar x is tending to 1. So
Right.
if it tends to 1, now if you look at your original expression, we had some 1 by 2 factorial plus you had some x bar x minus 1 by 3 factorial and stuff, right?
Right, right, yeah.
So all of these factors disappear, no?
Right, become 0, yeah.
Yeah.
Become 0, 0, 0 and so on. Denominator is x bar x plus 1 whole square, right?
Right, yeah.
So this is 1 by 2 by 2 square, right?
Yeah, 2 square, yeah.
Is equal to 1 by 8.
Right. Right.
Okay. So this was a little complicated one, but again, what I'm doing is figuring out a pattern where it fits some standard limit, right? You have to notice here that we are trying to like make it like this minus, it was this, but I added and subtracted a 1, right? So there will be a minus 1. So I made it look like this thing minus 1 minus this thing. And that is obvious that it will be Taylor series of this. The first two terms will cancel. And denominator also became this. Right?
Yeah.
And after that, it was not so hard as long as you can figure out that x tends to 0 plus x bar x tends to 1. Okay.
Hmm.
So this part I figured by L'Hopital by saying it is h bar h is equal to t, let's say. So then h log h is tending to log t,
Right.
and this limit as h tends to 0 is of the form infinity by infinity, because I can write it like this.
Yeah,
Ah,
yeah.
ah.
And then 1
Right.
by h and minus 1 by h square. So it becomes h on top. So it is tending to 0. This tends to 0.
Right.
And this tends to 1, therefore. Right? So we are getting it, right?
Yeah, yeah.
Okay. Uh, that's all for today. What I want you to do is practice more limit questions. So you have all your Allen books for limits, okay?
Yeah.
All of you have got Allen book where limit chapter is there.
Yeah,
Yeah.
yes, sir. Yeah.
Yeah.
Okay, then this
Yeah.
week just do Allen exercises. Allen exercises for the limit chapter. Next week we'll discuss all your doubts. So next week will be last class for limit discussion. Okay.
Right. Right.
Calculation of limits. We have to do continuity, differentiability, and those parts. Okay.
Yeah. Yeah.
So just practice a lot of the Allen exercises. Try to do review exercise and unit exercise and whatever is there.
Hmm. Yeah.
Right.
Yeah.
This chapter is very important. Make sure that you are very strong in this.
Yeah.
Okay. That's all for now then. I'll see you guys.
Thank you, sir.
Okay.
Hi, sir.
Bye.
Thank you, sir.